From the fiery hearts of dying stars to the icy depths of Neptune, diamonds have an incredible cosmic story. Join us as we explore how these precious gems form in space and make their way to Earth's surface. Stars are like giant cosmic kitchens, cooking up the basic ingredients for diamonds. Inside these massive balls of gas, intense heat and pressure transform simple carbon atoms into something special. When stars reach the end of their lives, they create the perfect conditions for diamond formation. Temperatures soar to millions of degrees, while crushing pressures squeeze carbon atoms together. These extreme conditions force carbon atoms to link up in a specific pattern, the same pattern we see in diamonds on Earth. When older stars explode as supernovas, they scatter these diamond seeds across space. Some of these space diamonds are incredibly tiny, smaller than a grain of sand, while others can be as big as small planets. Scientists have even found stars made almost entirely of diamond. They call them diamond stars, or white dwarfs. When a massive star goes supernova, it creates a spectacular light show that's also a diamond-making factory. The explosion releases more energy in a few seconds than our sun will produce in its entire lifetime. During this cosmic blast, carbon atoms get squeezed together with incredible force, about 1,000,000 times stronger than the pressure used in lab-made diamonds. The explosion sends waves of superhot gas and dust into space, carrying tiny diamond particles along for the ride. These space diamonds come in all sorts of sizes, from microscopic specks to chunks as big as mountains. Some of these diamonds fall to Earth in meteorites, giving scientists a chance to study them up close. The most famous diamond-carrying meteorite crashed in Egypt in 2008, and it sparkled like a disco ball when researchers cut it open. Let's follow carbon's amazing transformation from simple stardust to dazzling diamond. Carbon atoms start as loose particles floating in space clouds, but they don't stay that way for long. When these atoms get caught in intense heat and pressure, they start linking up in a special way. Imagine building blocks snapping together in a perfect pattern. Each carbon atom connects to 4 others, creating a super strong 3D structure that gives diamonds their famous hardness. This process happens naturally in space, but it can take millions or even billions of years. The carbon atoms have to line up just right, like a perfectly solved puzzle. This specific arrangement is what makes diamonds different from other carbon materials like graphite in your pencil. It's the same carbon, just organized in a completely different way. Kind of like how you can rearrange the same Lego pieces to build different structures. Let's travel to Neptune and Uranus, where something amazing happens. It rains diamonds. These ice giants have layers of methane gas in their atmospheres. When lightning strikes, it breaks down the methane into carbon atoms. As these carbon bits fall deeper into the planet, they experience massive pressure and temperatures around 7,000 degrees Celsius. This turns them into diamond droplets that fall like rain through the planet's interior. Scientists think these space diamonds might be millions of carats in size. The diamonds keep falling until they reach the planet's rocky cores, where they pile up to form layers of sparkling crystal. In 2017, researchers actually recreated these conditions in a lab using powerful lasers, proving that diamond rain on Neptune and Uranus isn't just science fiction, it's really happening right now. Now let's talk about how diamonds make their way to Earth through meteorites, nature's delivery service from space. These space rocks carry tiny diamonds that formed billions of years ago, long before our planet existed. When meteorites crash into Earth, they bring these cosmic gems with them. Scientists have found some really special ones, like the Almahata Sita meteorite from Sudan, which contained diamonds from a long-lost planet. These space diamonds look different from Earth diamonds. They often have strange chemical patterns that could only have formed in space. Some are so old that they're actually older than our solar system. The diamonds in meteorites are like tiny time capsules, giving us clues about how planets formed and what space was like billions of years ago. Scientists have gotten pretty good at copying nature's diamond-making process right here on Earth. In modern labs, they use special machines that create the same intense heat and pressure found in space. These machines can transform plain carbon into diamonds in just a few days, way faster than the millions of years it takes in nature. The lab-grown diamonds are chemically identical to space diamonds, but they're often more pure since scientists can control every step. They start with a tiny diamond seed and add layers of carbon, like building up a crystal one sheet at a time. While these lab diamonds are perfect for jewelry and industrial uses, they're missing the cosmic history that makes space diamonds so special. Natural space diamonds carry unique marks from their journey through the universe, like tiny bubbles of ancient gases or unusual crystal patterns that tell stories about their cosmic origins. Let's explore one of space's most amazing treasures, white dwarf stars that are basically giant diamonds floating in space. When medium-sized stars like our Sun run out of fuel, they transform into these incredible objects. The star's core, made mostly of carbon, gets squeezed by gravity so tightly that it turns into a massive diamond structure. These cosmic gems can be as big as Earth but much denser. A teaspoon of white dwarf material would weigh several tons. The largest known diamond star is BPM 37093, nicknamed Lucy after the Beatles song. The star's surface is so hot it glows with a white-blue light, while its crystallized core sparkles like a diamond with about 10 billion trillion carats. That's a 1 followed by 34 zeros, or... Let's explore the biggest diamonds ever discovered in space, starting with the famous star BPM 37093, nicknamed Lucy. This amazing star isn't just big, it's essentially a diamond the size of Earth. When scientists first found Lucy, they could hardly believe their instruments. The entire core of this white dwarf star has turned into a diamond crystal weighing around 10 million trillion carats. That's more than all the diamonds ever found on Earth combined. But Lucy isn't alone. Astronomers have found other massive space diamonds too. In the constellation Centaurus, there's a chunk of crystallized carbon 4,000 kilometers across. That's about the distance from New York to Los Angeles. These cosmic gems show us just how impressive nature's jewelry-making skills really are. While space diamonds are amazing, the ones we wear actually form deep inside Earth. About 100 miles underground, conditions match those cosmic diamond-making recipes we talked about earlier. The intense heat and pressure in Earth's mantle transform carbon into diamonds over millions of years. These gems then hitch a ride to the surface through special volcanic pipes called kimberlites. These natural elevators formed during ancient volcanic eruptions, shooting up from deep underground at incredible speeds. The diamonds we find today are actually billions of years old, forming when Earth was still young. Think of them as time capsules from our planet's early days, carrying clues about how Earth formed and changed over time. South Africa, Russia and Canada have some of the richest diamond deposits, each telling its own unique story about Earth's history. Space mining isn't just science fiction anymore. It's becoming a real possibility for the future of diamond harvesting. Several companies are already developing technology to mine asteroids and other space objects rich in diamonds and precious materials. These missions would use robotic miners to extract diamonds from asteroids, which often contain higher concentrations of gems than Earth's mines. The biggest challenge is getting there and bringing the diamonds back, but engineers are working on solutions like solar-powered spacecraft and automated mining robots. While we probably won't see space mining operations next year, experts think we could be harvesting space diamonds within the next few decades. Some asteroids could contain trillions of dollars worth of diamonds, enough to make Earth's biggest diamond mines look tiny in comparison. Thanks for joining us on this sparkling journey through space. From star explosions to diamond rain, we've seen how these gems tell an amazing cosmic story. If you enjoyed learning about space diamonds, hit like, subscribe, and share with a friend.